Welcome everyone. In this video I'm going to show you how I assemble the electronics for another project. So I did not want to include this part in that video because it would be too long and people are not watching the whole video anyway, so it might be worth to split it up into several parts. So that other project consists of two stepper motors, which are the main parts of the project, and they have to be controlled, and we have to send some commands to these stepper motors and operate them in a certain way. So this circuit will realize that, and as you can see, we have a few parts here, some electronics and some mechanical parts, connectors and some plastic things. So I will go through all these parts, and then I will dive in and assemble everything. So let's start with this thing in the middle. So as you can see, we have an LCD here. This is a Nokia 5110 LCD, as you can see it here. So it's very simple because it uses SPI, so I can connect these to the microcontroller via SPI, and it will work nicely. So we have this thing, and this kind of construction can be familiar to you from my previous video where I had the same thing, where I showed you how to make a control panel for a stepper motor. And I basically borrowed the idea from my previous project, but I added one more stepper motor, but the basics are the same. So we have two buttons. I already screwed them in. So the buttons will have different functions based on what we try to do. For example, move the stepper motor or start and stop the stepper motor, and so on and so on. So that will be there. And as you can see, there is a nut here, which is melted inside. So I just took this nut from this rotary encoder and then just pressed it into the printed part. And yeah, as you can see, I can just screw this in. So we will have this panel together with the rotary encoder, which is rotating and also has a switch, as you can see, and we will have this very nice knob for it. So yeah, it will look like something like this. It's quite nice, I think. And the reason why I do this is because I want to put this thing in a plastic box, but I'm really bad at cutting nice holes, especially when I have to cut something like this, rectangular hole, precisely. So what I do is that I just roughly cut the outline of this thing, or something slightly smaller than the outline of this, and I drill the holes for the panel, and then I just simply put this in. So this panel will cover the ugly cutting, and it will look like semi-decent, I would say, because the printing, as you can see, still contains some flaws here and there, but it's more nice in this condition than with this. If I butchered this box, that would look much worse. So that's why I have this kind of panel, and it's also, yeah, it keeps everything together, so it's nicer. So this will be the control panel part. And what we will have here is, of course, the rotary encoder with this knob, but we don't need this. And now you can maybe notice that I'm more towards the STM32 blue pill microcontroller. I'm still using the Arduino IDE to program it, so I'm not using the environment for the STM32, the Cube IDE, not yet. But I'm at least using a more powerful microcontroller. So I will use this microcontroller to take care of the LCD, the buttons, the rotary encoder, and to control two of these guys. So this is an easy driver, a stepper motor driver. And this is the same. If you check my other video up here in the corner, you can see that it works in the same principle as any other popular stepper motor controller. It takes a direction and a step command from the microcontroller or signal, and then it moves the stepper motor by sending out the power to the two individual coils in the stepper motor. So this is the brain of it basically, and we can adjust the current with a tiny potentiometer here. We can add the power supply. We have MS1, MS2, which is the microstepping, so we can have 4 different microstepping set up with this kind of configuration, like full step, which is with the most popular stepper motors is 200 steps, and then half step, so 400 step, quarter and 1/8 steps with this particular driver. And that's perfectly enough for me, because I will use the 400 steps per turn for the microstepping, which is more than enough for me. So this is about the electronics, and then that's why I have this other panel. I tried to do something here with the printing, but the printing got bad. But here, as you can see, I used some kind of nuts which can be like pushed into the print, and as you can see, we have a few screws here, and these screws has a reason. So I just unscrew 2 of these, and I show you what is this. And this also justifies why I picked this kind of driver, not only because I have them, but as you can see, there are 2 holes here and there. So I designed this plate to accommodate this driver, or these drivers, and then, yeah, as you can see, you can just screw these things here and there. It's not perfectly precise, so I might have to adjust a little bit, but yeah, whatever. So this is what I want, because when I put everything in the box, of course, first I will put it on this. This is the bottom of this box. So what we can see here, I will basically just put it here, use some hot glue, but and then this will be here. But it's more cleaner for me, and I can arrange the cables in a better way if I have the 2 controllers here, and they are not all around the box, but they have their dedicated spot. So this is the purpose of this other plastic plate. And yeah, I have to learn how to use these nuts a little bit, because I was still struggling with them a little bit, but it works so far. So that's what we have here. And then basically the last few parts is I will use this 2.1 millimeter jack plug in order to feed these 2 guys with electricity. And then since these boards have 5 volt output, I can use it to power this thing here, for example. And that's very good, because I will not always connect this to the USB. So I want to use it without USB. So I want a standalone power source, and then this can act as a power source. So yeah, I can make it independent from the wiring. And then I chose this kind of connector with 4 pins in it for the stepper motors. So I will have 2 stepper motors. This part of the connector will be inside the side of this house somewhere. And then this goes to the end of a stepper motor wire, for example, like this. So this end is going in the stepper motor, and now I already have these ferrules on it. But then these 4 things will go inside this housing. So this will be better and more sturdy and strong, instead of just soldering everything here and having the cables everywhere. So I will use these connections for the 2 stepper motors. And then yeah, I have these small prototype boards and 2 resistors and 2 capacitors, and that will be just used for this rotary encoder. Because what we have is that if you look at this rotary encoder like this, so 3 pins are here and the 2 pins are here, then the middle pin and the left side pin is the ground, and then this is one of the rotary encoder pins, and this is the other rotary encoder pins, and this is the pin for the switch. And then what we have to do is that the encoder pin goes to the ground via capacitor. So we have the two capacitors here, and then one of the resistor goes to the 3.3 volt and the other resistor goes to the 3.3 volt. And then also where the resistor meets the rotary encoder pins, so on the two sides, those pins will go to the microcontroller here. And then also this switch pin directly goes to the microcontroller, and that's all. So I will show all these parts, but I think the main attraction here is just how I solder these things and how I connect everything. Of course, these connections will be on the website independently for the rotary encoder, and then for these, because it's a bit too much connections because of the wiring of this thing, and I don't want to make it too complicated. So what I should do now is I should just solder this quickly. So we will start with that part, and I will explain everything if something happens, but I will speed up the video here and there where there is nothing extra to discuss. So let me just pick the parts, and then I will start the work. So this part is done, and it might look a bit confusing, but I will explain it now, and I also put the drawing on the website. So this pin over here, the right side, this is the ground, as well as the middle pin down here. So they are connected together with this wire, as you can see. And I also told you that the input or output pins, however you define them, so the two rotary encoder pins are also connected to the ground through a capacitor. So I put these 100 nanofarad capacitors to the pins, and then they are connected to this wire together. So you can see that they go from these two sides, hopefully it's visible, and then this is the capacitor, and then it goes to the ground. And this part might be confusing, but what happens here is that I have the 4.7 kilo ohm resistors, and then those resistors go one side of the resistor, of course, one pin of the resistor is connected to the rotary encoder, and then the other is common with the other resistor, because they will be connected to the 3.3 volt power source or voltage of the STM32. So they meet in the middle, but of course they are not connected to the ground. So as you can see, rotary encoder pin here and here is connected to the resistor, and then the resistors are they meet in the middle, and then I will put a wire here to go to the 3.3 volt, and then I put another wire here to go to the ground, and then I put another wire here to go to the switch pin here, so to the pin which will be reading the switch state, so this, click. And then I will put a wire here and here, so on the two sides, to the rotary encoder pins. And then they will go to the corresponding pins on the STM32 again. So in total, 3 pins will go to the ports, and 2 pins will go to the, let's say, power. So one of them is the ground and the other is the 3.3 volts. And yeah, that's all about this. So the next step is that I will roughly size the cables. I will use some extremely flexible cables. I really like them. And then I will solder them into this board. So there will be 5 cables in total which will be soldered. And then we decide what's the next step. So I have these cables. They are perfect for signal transmission, and as you can see, they are like extremely flexible. I really like them because yeah, they transfer the signals properly, so I haven't had any problems with them so far, and they are thin enough and flexible enough to put them in a box, because sometimes I get a problem with the box constructions that the wires, I have too much wires in the box, and then the wiring itself becomes so rigid that I cannot really assemble the box. So this cable helps us to avoid this crowding issue with the cables with 2 things. One is that it's thin, and the other is that it's very, very flexible, so I can squeeze everything together. And yeah, it's not really scientific, but we know that the cable, let's say, will start from the bottom of this, now the bottom of this box, and it will come roughly until the surface, but let's say that it will go across the box, because maybe it will be somewhere here, but then the STM32 will be in this corner, so it has to cross from here to here. So I just roughly eyeball that distance and say that, okay, this will be my standard cable length for this project, for this part of the project. So that's how we will work. And yeah, so this is, yeah, as you can see, it's like 12 centimeters or 5 inches. And I really don't care about the cables, because I know, I mean the colors of them, because I know where they start and where they should end. So it just really doesn't matter, but at least I want to distinguish the power, so that will be done. And let's say I will bring the switch signal with the other red, so 2 red and 3 blue. So I can really recommend you this kind of tool, because yeah, you can cut with them, and then you have different size of cables, AWG or millimeter cross section, and it's really easy to strip the wires. So as you can see, yeah, this is done basically. And then this is like a cheap tool, but it's a must-have tool, because it makes your job very, very easy and very quick. So as I said, I want the 3 volts with red, so that's the middle here. And let's just squeeze it there. And I immediately solder it before I lose the cable. So everything looks great, and I cannot see any short circuits, and everything seems to be connected. So I just have to basically put it in this part without destroying the cables, which I just soldered. And this will be the end, because yeah, I cannot turn this more. So just as a demonstration, I put on the knob. And of course it should not go all the way like this. There should be a gap between this board and the knob, otherwise I cannot push the button. So what I do here is a bit cheating. So something like this. There we go. I can push the button and rotate the encoder. It's a bit wobbly, but oh, it's good. So now a similar exercise should be done with the buttons. So these two guys here and here. And for the buttons I also need the pull-up resistors, or I could use the internal pull-up resistors of the microcontroller, but I don't really trust it. Sometimes it works, sometimes it doesn't work. So what I just have to do is I have to use another panel here. So that's why it's good that this thing is a bit larger, because yeah, if you see the arrangement, it will be yeah, something like this. But then I can put this here, and actually I can make a node here for the 3.3 volt and the ground, which can then go out to the LCD and to this part of the circuit. And then I can also put the two resistors for the buttons here, because what it should be done is the 3 volt directly goes here, and then on the other side one wire directly goes back to the microcontroller, but then there is another wire going down from the other side of the switch, and it goes to the ground through a 4.7K resistor. So 4.7K, as in the case of this circuit, is the same. And for that, or for those 4.7K resistors, I will use this tiny prototype board, and that should be enough. So I will cut some similarly long cables as these, because they will basically go to the same spot, more or less. And after that I will solder the resistors here, and then solder the cables and the resistors together. So let's just test the buttons, how they work. So they do not conduct when I don't press them, so it's a normally open circuit. And when I press the button, you can hear the beep, so then it goes to closed. So it closes the circuit, and that's how I want it. So all we have to do, again, is just a bit of soldering practice. So one side of this button will be used as the, let's say, input. So the 3.3 volt will go in there, so on one side, and it's not polarized or like a capacitor or some other components, so it doesn't matter how we wire it. In fact, I can put this here, and I will do that because it's more easy. So I guess this circuit should be fine like this. So we just have one wire because it's a parallel connection, and we can press the buttons properly. Okay, so these connections are done. So this will go to the 3.3 volt. And in fact, to further decrease the complexity of this circuit, I can put it here because this board will be always powered with the 3.3 volt rail. So I can like shorten this wire and solder it here like this. And I will do that right now because it makes our life much easier. I haven't planned this thing, so sometimes I come up with the things during the assembly, because then I see it with the parts. I have everything drawn, or most of the things drawn, but these things are not visible on the drawing for the first time. So and this is just a prototype. Done. Okay, so now we simplified everything, and in fact we just have one 3 volt pin. And what I will do also that this also has a 3 volt source, so I will just simply solder it here as well later. So then everything will be much simpler, and also I will bring the ground here as well. And in fact, I pick one from each buttons, one wire from each buttons, and they will go to the microcontroller because they will be the feedback for the buttons, of course. But then these two guys has to be connected to the ground via a 4.7K resistor. That I can also do it here. So now I see that okay, one side of the resistor will be soldered to this wire, and the other side will be just soldered on this part or this side of the circuit because the ground is running here. So I will do that again. So I will simplify everything, and a lot of things will be realized on this small circuit board. And actually that's very good because the rest of the board, this basically will be very, very simple. So I will just get two resistors and bring them here. So we have the resistors, and as I said, they have to go to the ground, which is here is running in the middle. So I might just bring them under this wire somehow. So this is also done. So at least the switch is now at their corresponding places in the circuit. So they look fine. I cannot see any short circuits. So now comes a bit more longer work. I have to prepare some cables for here, for these connections, and I'm thinking, what should I do? Should I use these DuPont connections, like these jumper connections, such as this, because I can make them myself. I have this plastic housing and also the metal thing which is inside this, and then I can press the cables here, or I just have to keep like long enough cables and solder everything on this. I don't know which is the best solution, but I think I might take the time and make the connections because it's a bit more easy to assemble the things. So what I have to do again is take several cables, 8. 2 out of them will come here, so I can recycle these cables. but then 6 other cables have to be prepared. So yeah, I just cut a few cables. But I think this length is more than satisfactory. So this is the kit, and luckily I have these with the multiple connections, if I can remove them. So this one is with 1, 2, 3, 4, 5, 6, and that's perfect, because then I can put it on this the other way around, and that will be fine. But I cannot use the 6th one because it's a funny arrangement. We have the ground, the backlight, and the VCC, and I know that the VCC and the backlight has to be connected together. So in fact, we just need 5 things next to each other, because we will use the RST, CE, DC, D-in, and CRK, which will come from the microcontroller. So they will be going here, and then the rest will go to this board here. So I just need 5. So in fact, I need 5 of these wires as well. And in fact, I will make a separate video with a better camera setup and better camera than this here, to show you how to assemble these kind of connections. I have this and the other type, which I don't remember exactly, XH 2.54 maybe. This kind of connections. And I have the tools for that, and I will show you how to make them nicely. But I can still show it in one example here with a bit less details. So this is the tool. It's a crimping tool, and you can see that we have these valleys here, or notches, and then we have these teeth, and they compress this metal part together and then grab the wire which is inserted in the end of this thing, and then it opens up. So what we have to do is that first we remove one of this thing from the rail, and then you can see or not on this, because this camera is not for this kind of things, but this is the end which will go on the jumper pins, and then at the other end there is this 2, let's say, V-shaped metal, and that grabs the cable insulation. So it grabs the insulation, and then we have a rectangular thing there which grabs the conductor part, so the wire itself. And these 2 things are folded with this tool. So what we have to do is we have to remove roughly 2 to 3 millimeters of the insulation, so not too much really, and then I just twist it so it will not fall apart. And then what we have to do is we see that there are like 2 different kind of notches here, or valleys, and I'm going to use the smaller one here. So these V-shaped metals should face these valleys. So what we will do is that we have the back of this metal, and then we press the back of this with the tooth here. So now I just now it locked itself. So I press until the end of the metal part of this connector reaches the end of the valley. So that's basically 2 clicks. So 1, 2. And now I insert the cable, and that's why we need just 2 to 3 millimeters. I show it why. Because this length here is limited. So as you can see now, this is how it should look like roughly. So this is maybe a bit too long, but what happens here is that we put it in like this, and then this tool will fold this V-shaped thing around the insulator, and then it will fold this rectangular part around the conductor, the wire, and then it makes the perfect connection. So that's what I try here. So I will just try to push this in with the appropriate amount of distance, and then I just start crushing it. And now I release it, and it's done. So it's not very visible because of this camera, but you can see that this part, the end, is grabbing onto this plastic or silicone part of the wire, and then this rectangular is perfectly folded in like this, and that is grabbing the wire, and you can see that now I'm pulling it, and it works nicely. And then here again there are two sides, and this side, so basically the wire side up, has a small metal part sticking out, and that metal part which is sticking out will grab into this plastic part. I don't know if it's visible, but the whole part here. So we have the bigger opening, we just press this in entirely, and now I can insert it. So this is done, and now I speed up everything, and I just do the same exercise that I did here, so you will see the end result. So as you can see, this is done. It's a solid connection with all the 5 cables. So now I just have to solder these cables into this microcontroller according to the pinout of the Nokia LCD. And I will also solder the cables for the buttons and the rotary encoder, and we will see if it works or not. Okay, so as you can see now, I prepared everything for the assembly, and I know the connections and everything. I will put the picture of these connections to my website, so you will be able to see it, but I'm not going to discuss it or tell it that, okay, now I'm putting this wire to here and there, because that can be boring. So all I will do, I just make some temporary solders to the microcontroller, and then we will see if the screen starts up and if I can do anything with the buttons, and if that works, that will indicate that I can proceed with the work, and I will just add the motor controllers, and that's all. So I will just speed up this part, and I will discuss after I finished. Okay, I just removed everything, cleaned up a little bit and removed some wires from the other side of the PCB. So let's see if this works by connecting this to the power supply. So as you can see, we have the message there. So this so far works. And then we have the different values. So now the values are expressed in turns per second or turns per second squared and so on. So sometimes there can be some funny values. But yeah, as you can see, we can modify the values, but this has to be a bit more tweaked, so to say, because as you can see, the values change just a little bit. But yeah, this is for now. So yeah, we can change the number of turns. And if we use the rotary encoder, you can see that one click of the encoder is just one increment. But I added some other feature that if I press the button, then that adds 10. So if I keep the button pressed, then we increase it by 10 all the time. So it goes quickly. So if you want to add a lot of numbers, you just keep this pressed and then it will go by 10 up. But if you want to decrease it, then you keep this, and this subtracts 10 from this number as long as you keep it pressed. There is a small delay between reading the button status over and over, so that's why it is not decreasing so drastically. And then with the rotary encoder we can fine-tune it. And then of course we have the other menus, and yeah, we can change the diameter of the bobbin, as you can see, and so on and so on. And yeah, a lot of things can be changed. Some things still need some tweaking, and I have to check it because it's not really checked in practice, because it was only made for demonstration so far, but not for, let's say, work. So this has to be improved. So now we can see at least that this works. And now what I just want to do is I want to add the two drivers for the motors and see if they work as well independently. So with that, I just want to start some random movement of the motor and see if the circuit works. And if it works, I will just put it in the box, and then yeah, as you saw it, I will work with the mechanical structure and also with some parts of the programming. So in the final arrangement on this plastic plate, this will be the distance roughly between the motor controller and the microcontroller. So we will not need two long cables because technically, yeah, this will be the largest distance that we have to fill up, and also to this motor controller we will not need longer than this. So roughly, I don't know, 10, yeah, it's 10 to 12 centimeters of cable. And each motor will use 5 different connections towards this microcontroller. So the ground, of course, has to be connected between the two boards. And then we have the MS1 and MS2, which are the microstepping. So they will go to these digital pins here, B1, B0 for one of the motor controller. And then we have the step and direction, and that will go to A8, A9 for one of the motor controller, and then for the other A10, A11 for the step and direction, and MS1, MS2 will go to B10, B11 respectively. So it's not a big deal. And then I will use one of these boards to provide a 5 volt to this circuit. And then we will see what happens. Hopefully I will not burn it down. So what I have to say here is, or what I want to say here is, I will directly solder together these things. I will not struggle with these DuPont connections. It does not worth it because this will be a permanent connection anyway. and I just have to cut 5 cables per motor controller, so 10 cables, or 9 because this can be used, and that's all. So let's just speed up everything, and after I do some progress I will talk again. So I connected everything except the stepper motor, obviously, and the power source. So that has to be done, and then I will check if these boards work properly. So I have to figure out how to make these connections, because at the end I will use this, as I said, this jack plug, 2.1 millimeters, but I don't want to use this right now because there are no holes on this box yet, and I don't want to drill it right now. So I will just wire it up with some temporary wires. So I will get some wires and I will attach the stepper motor, and hopefully nothing will blow up. So I will use this small stepper motor with a planetary gear because it has bare wires, so that's very good. And I will use these thicker wires because they are for, I think, 2 amperes, and they are also these flexible wires, so at least I can test them, how they behave. But I just need some very tiny piece of them. So let's see how they... I don't even remember the diameter of them. But these are too thick, so I will have some issues putting them through these holes. Okay, this will not work, so I will get some other cables, but this I keep. So let's use these rigid old style cables. So these were the cables that I was talking about. I was using these kind of cables previously for projects, and it was quite difficult to put them in any kind of enclosures because they are very rigid, and then they are also a bit thicker. So let's just solder everything together. Okay, so I wired up one part, only this stepper motor controller, and then this is corresponding to the first motor, so this drives the first or main shaft. So then, if I use this display, we have a manual movement of the main shaft. So I step in that and start to rotate this. So you should hear some noise from here. So it moves the stepper motor, and of course you cannot see any movement on the main shaft or the output shaft here. So you have to trust me and trust the noise, just because this is a 1:100 or 100:1 planetary gear. So this has to turn a lot in order to have some noticeable movement here. But at least listen to the noise. So it works, and I can see some very slight movement after this much turns. It turns this direction, so it works. So yeah, the next task is to check it with this motor controller, but I think it should work because I wired up in the same fashion as I did with this stepper motor controller. So I will not check it, but I turn this off because it draws a lot of current and it is getting hot. At the end, this guy will have a heatsink. I have a heatsink specifically for this kind of chip. So it's a wide and tall chip, so it will be cold enough, and I will play around with the currents to find the proper current which can still move the shaft, but it doesn't heat this thing up too much. So that's one thing. And then at the end this will be in a box when everything is finished, but as I am working on a prototype so far, everything will be out of the box. So it will be on this board, but I will not set up the connections to put everything here. I will not use this jack plug, and I will not use this kind of converter or connector, because if something happens or if something has to be modified, then obviously I have to disassemble everything, and maybe I have to modify some stuff. So I don't want to finalize the enclosure until I figure these things out properly. But yeah, as you can see that this works, and the purpose of this video was only just to show you some tinkering and show you some assembly, but nothing really educational, so sorry for that. But keep following this kind of playlist because this whole project is in the same playlist on my YouTube channel. And if you want to look for more information, first look around in that playlist, so you will find maybe more videos. If you watch this video, let's say in the middle of 2021, then you will see much more videos than if you would watch this in 2021 January, because this project will progress. And when I have like the final thing, which is working as it intended and it's reliable, then I will have like a big summary page on my website, and then I will publish everything. So you can build your own. So I will publish the wiring, I will publish the source code I wrote, and then the mechanism, how you can build it up. I will have the list of the parts, so where can you buy this knob, this stepper motor controller, these wires and whatever. So you can follow everything. and you can build your own machine for a fraction of the cost. So that will be the ultimate goal of this thing. That obviously I learn a lot from this, but hopefully you will also learn by watching my videos. And then we will together build this machine. And also, if you will have some sort of comments or recommendations or suggestions, then I will sort of build in that thing into this project and work with it. But yeah, I think I finalize this video here, because from here there are not too many steps until I move everything together with the mechanism and the electronics. So then, as you could see it in the previous video, it works properly. And then as I suggested there with the steps, some more progression will be done, and there will be some more iterations of this machine. So for example, the larger motor, and maybe some closed loop control for the stepper motors, and so on and so on. So those will be implemented and then updated accordingly. So there will be always a new video about that thing. So yeah, that's all. But you can see that this works now nicely. And I'm very happy that this control panel works as I wanted. And it worked for the first time. So I just wired a lot of things together on the during making this video. So that was a good surprise. So yeah, I hope you learned something, and I hope you found this kind of video useful or entertaining or anything. And once again, please check the description of the video, check the playlist, which is also in the description, go to my website, the link is in the description, and check the resources, because some of these wirings and schematics will be already there. And if you found this project, for example, useful, you can also donate me, so I can buy these parts more quicker and maybe better quality and things like that. And that will help to progress this building much quicker and with more quality parts and so on. And please don't forget to subscribe to my channel. That helps me a lot. Leave some comments if you have questions, suggestions, and that's all. So I hope you learned something, and see you in the next video.